All right, let's talk about it page by page. First page here, and a lot of the stuff isn't on here. It's going to be on the board, okay? The first page has a lot of these kind of questions like these here, all right? Then it has some questions, and the questions it has are going to be on those topics when we get to the end. I'll talk about those. Second page is all of these kind, where you have a chart, and you've got to figure out what's happening with the rate, what's happening with the changes. There's two of them only, because they're kind of long. The next one is going to be, is this mechanism consistent? There's going to be two of those. And there's going to be multiple choices, and it could be more than one answer. And then finally, number 12 says exactly what you expect to say. And as much detail is given in the book. Explain the 4 stages of how a heterogeneous catalyst works in a catalytic converter. It is worth 10 points. And if you haven't read it yet, or if you have, you probably forgot it because of all the snow days, it was about 2.5 weeks ago. All right, so that's the test. Let's talk about what I can help you with on it, which is each of the types of problems you're going to see. Let's look at this first kind here. Now, I will say this. I think I already hit that once. Let me see. Yeah, that's what I thought. I will say this. Look at when I put it in this method, which we've seen multiple times, Shania has no problem with it. All right, it's when we have to do it in lab and physically do it. So the fact is, as much trouble as you had in lab, not just Shania, but everybody, as much trouble as you have in lab understanding the dilutions and the concentrations, and because the numbers aren't perfect, all right, it actually turns out that the homework problems and the test problems are much easier than a lab. All right, it's unfortunate. It proves that you don't really understand it 100%, but it should make your grades a lot better. All right, let's take a look at here. First of all, what's the order of each of these? Wow. First mistake to make is A, B, and C. I don't look at the actual coefficients. I look at only the rate law expression. Okay. What is the order of A? Victor. 1. Everybody agree? What's the order of B? 0, because he's not in the rate law expression. Don't expect to see a 0 above B or any other guy. It's just not going to be there. Anybody who's not there means he was not involved in the slow step. So 0. What about C? Second order. Next one, Victor, you're out. You're not watching the review. Order of the reaction. What do? Victor. Go ahead. 3. Why 3? Because you have to add them up. Okay? I was waiting for it. All right. Now, this is the application part of it. That's pretty easy. You simply look up the exponents and then you add them up to get the total order of the reaction. Now, this is the application. What I would recommend doing is simply putting these underneath it, all right, and seeing what happens. All right, 2 times. I'm doubling the concentration of A. So 2 raised to the first power. B, I already see he's not there. I don't have to put him in there. If he's to the 0 power, he's not going to do anything. 4 raised to the second power. All right, so that's going to be 4 squared is not 8. Everybody agree?
Yes.
I was getting a look. Somebody out there was not happy with that. And then 16 times 2 is? So I hope you all put 32.
Yes.
Do I put X's up here? No. It's just a change. That much of a factor is changing. All right, let's look at the next one.
I didn't put the X either.
Would we lose points for that?
Yes.
You've got it. I just seriously though, this is a legit question.
Shh. One question at a time. What?
Okay. So you know how they gave the problem and you said you have to write the problem using intermediates and crossing out and stuff? Do we need to know how to do that?
I'm not going to have questions that are that hard in the test. I said that when you were doing those. They're not going to be that hard. They're going to be basically like these. It's very simple.
Okay, so we're not going to have
You should understand what's going on with that, but no, I'm not going to have a specific question where you have to cross out the intermediates and all that stuff. I mean, I went over that, and I hope you understand it. It helps to understand what's going on, but they're going to be more basic like these. And let's look at the next one. Quarter of A. So 1/4 raised to the first power. B, I don't care about because these are the 0 power. And 3 squared. 3 squared is 9. 9 times 1/4 is 9 1/4. No, what is it? It's 9/4. All right, and you could do that if you wanted to, but you could put it into a.
You forgot the X again.
You could put it. I'm not done. You could put it into a decimal if you wanted to. You could put it into. What would it be if it was in a fraction? Another way to write a fraction for it.
2 1/4.
2 1/4. Okay, but either way, that's how much it's changing by.
I'm not even.
It's not going to be 9 1/4 though. That's what people do. The other thing people leave, and it's amazing to me, at this point it should not happen, but people will leave it like this in their blank answer, 1/4 3 squared. I do not want that. I want a final answer for what actually happened.
You're all right with decimals,
All right. Yeah, but again, for these kind, it's a lot easier to just use fractions. There are places where it's a lot easier to use decimals. This one's a lot easier to just keep it in fractions. Okay. All right. Let's look at this last one. 1/4 of A and 2 times C. So 1/4 to the first power, 2 squared. Now the reason I put this one on here because what happens? 4 times 1/4 is 1, not 0. If no change happens, you don't put down 0. You put down 1x. Okay. All right. That's what will happen to the rate. Nothing, basically. But nothing doesn't mean 0. Okay. All right. Now let's look at this guy right here at the bottom. And I think I probably have room on the next page to do it better. Yeah, a little bit more room. For each of these, you have to show me the work the way I said to. All right. Find 2 trials where everybody's kept the same except for one guy. All right. So I look here between trials 1 and 3. I've got him held the same and him held the same. C and A are held the same. B is changing. I could use that one. Any other ones you guys use? Between trials 2 and 3?
See, that's where I couldn't get it to work out.
Well, let's take a look. In both cases, I could use either one of those trials. I would recommend, between the 2 of them, I like Abby's choice better because B is held constant, C is held constant, and A is cut in half. It's an easier number to see when you're looking at what happens to the rate. So here's what I would write down, and this is the way you must show the work. Even in the homework, I didn't give full credit if you didn't show the work. You would simply write down trials 2 and 3. That's what you write first. And then underneath that, you would write the rate law expression and put down what happened. Rate law expression, rate equals K. A, I better write it over here. It's not going to have enough room over there. Rate equals K, A to the X, B to the Y, C to the Z. Okay? And underneath that, what happened to each one? Well, between trials 2 and 3, A got cut by 1/2. Between trials 2 and 3, he stayed the same, and so did he. So there's my equation. What happened to the rate? The rate went from 9.6 to 2.4. What happened? How much different is 2.4 from 9.6? And by the way, if you just divide those on your calculator, it will give you a whole number, 4 or 1/4, depending on how you look at it, 1/4. All right? So it's basically 1/2 to the x equals 1/4. What must x be? 2. It must be a 2, because when you square 1/2, you get 1/4, right? And that's how you know this guy is now a 2. All right, so we know A is second order.
I divided by 9.6, so I do 1/4, so I got 4 equals.
And if you did that, that's fine. All you'd have to do is look at this guy the same way too.
But I didn't. That was
Right,
the problem.
that's the problem. So you have to be consistent. Either way would work. All right, so now that I know A is second order, I go and I find 2 places. Now, we saw in the past, there could happen, and possibly on the test as well, where I don't have any other trials where everybody's held constant except for one of these guys that I haven't found yet. That's okay, because I now know what A is. I really don't have to hold A constant. However, I can. I can certainly find, in this case, trials where A is held constant. All right, which 2 trials would you take next?
1 and 3.
Okay, so I take trials 1 and 3 now
Yes.
because I'm holding A constant, B is changing, and C is not. I could do that. Any other choices? No, I guess not. That looks like about 1 and 3 about the choices here, right? Yeah, what? Yeah, no one?
Do you have to show the work for finding B or no?
Yeah.
Because if you look at the rates, they're meant.
I realize that, but I need, look, at the whole point is, in every one of these cases I could do in my head. I could have absolutely done in my head between 2 and 3. He's being cut by half, he's being cut by a quarter, I know the answer. I know you can, but in order for me to give you any partial credit, you have to say, this time I'm using trials 2 and 3, is it, no, 1 and 3, 1 and 3, and then you have to show me rate equals K, A to, we now know second power, B to the Y, C to the Z. All right, and you have to show me what happens to the rate between, I know it's going to be nothing. Nothing happens to the rate, so it's a 1 equals 1 squared B goes down by 1 or no, up by 1.5. All right, to the y and 1 to the z. So you have 1.5 to the y equals 1, and that's y. You're explaining to me with that work why you understand why y is what, by the way.
Yeah.
Notice what I'll get for an answer there. Another mistake. You'll make it because you're falling asleep right now. 1.5 to the y equals 1, y equals 1. People will do it. I guarantee you someone will do it. Is a 1 there? They'll put a 1 there. What does that exponent have to be such that if I raise anything to that power, it has to be 1? It's 0. It's got to be a 0. Okay? All right. Now, I would do the same thing for C at this point, and I found, so what have I found so far? I found out he's second order, he's 0 order, right? What do I do for C? Which 2 trials did you take for C? 3 and 4 you took?
Yeah.
Because I'm holding A constant. I don't care about B anymore. I know he is. So this one I won't show you, but you know what to show. This guy triples. He triples. What is C? First. So now I got all the orders. You would have to show the work for that, but I'm going to save myself a little bit of time and not. I got 2, 0, and 1. I still have 1 step left to do. I also get people who will just not do this last step. So let's do that. Rate equals K. A to the second. B to the 0. C to the first. Now, you have to plug in not changes this time, but one trial, any one trial. So if we take that trial right there, what I would plug in was rate is 2.4 times 10 to the negative 6 molar per minute. Equals K, 0.2, you're all 0.2, that makes it easy. K, 0.20 molar squared, 0.20 molar to the 0 power, and 0.20 molar to the first power. Now here's where your units, I know you hate units, all right? I realize they're going to come out to be ugly, but they're not that ridiculous, all right? I have 2.4 times 10 to the negative 6 molar per minute equals 0.2 times 0.2 is 0.04 times another 0.2 is 0.008, right? So 0.0080. And I have molar squared and another molar is molar cubed. Why do I not count this guy? Because he is raised to the 0 power. That makes him 1. All right. So I have 0.0080 molar cubed and that number, K, and that number over there. K would therefore equal those two guys divided. When I divide it, I'm dividing molar per minute by molar cubed. Well, what's that going to give me? Molar to the negative second per minute, which would be basically, your units are going to be molar to the negative second, minute to the negative first. Or molar to the negative second. So anytime something's in the denominator, it's basically to the negative power. What do you get when you actually divide those, by the way? How much?
3 times 10 to the negative.
3.0 times 10 to the negative 4th, you said? Does everybody agree with that?
Yeah.
All right. So there'll be 2 of these.
What's our thing?
What's that?
What's the stupid? I don't even know what it is. Units again. I can't read that.
Molar to the negative second, minutes to the negative first.
In our rate law expression, do we have to put the b since it's to the 0 order?
Well, you have to put him in there. I mean, just to show me again that you know what it means. But I understand what you're saying. In my other ones, I didn't put him in there because he was 0 order, so you could have left him out. I suppose I wouldn't take off for that because technically you don't have to have him in there. But I'd like you to show it just so I know that you know what it means. All right. So if you got a guy who's 0 order, you have to at least solve for him. But when you go to do K, you're right. You could leave him out because he's not really there. Great.
Do we have to write rate equals K, A to the X, B to the Y underneath?
Absolutely.
No, like for every
Yes,
trial?
absolutely. Because it's going to change each time. The first time it's going to be A to the X, B to the Y, C to the Z. Next time it's going to be A to the second, B to the, you'll figure one out each time. All right? So, yeah, absolutely. Victor.
You have to rewrite it like rate equals whatever the K was, the A, the second, B, alright.
Asprey.
No, he's saying
asking,
at the
like,
very
what's
end
the
you have to
final
say rate equals and then.
No.
K
If you
and
solve for
then
everything, the last thing you got to do is, your last answer is going to be K equals.
you don't have to read.
And somewhere along the line, you should have, as you found out, X equals 1 or Y equals 2 or Z equals 0, you should somehow, of each one of those, put a box around them. So no, those are your answers. That's your rate law expression. You don't have to replug them all back in and show me the final answer. All right. So 2 of those. And they're obviously worth quite a few points because we spent a lot of time on those, including 2 labs on those.
Yeah.
Let's look at the graphs.
Let's just look at
What kind of questions could I ask you about all of these graphs? Well, the first graph, I guess before I even put those up here, let's look at this one first. You have to realize what this is a graph of. This is a graph of, if I were to ask you what the equation would have looked like, all right, and let's just call these guys, we had A, B, and C. So I could ask you that. So say my question was 2A yields B plus 4C. Which color represents B?
Square. Yellow.
The squares or the yellow? Everybody agree? Let's talk. See if you can figure out why I'm saying this. I'm going to tell you why in a minute. Which color represents A? Red. Okay. And which color represents, obviously, that one on the left is blue for last one. All right. See if you can figure out why. Because as I graph this is the graph I'm doing, okay? This is the only guy who's a reactant. And if we start with stoichiometric amounts, he's going to start at 2, all right, and decrease in an exponential fashion because he's losing, at the beginning, the reaction happens quickly. And then it peters out towards the end because you're basically losing, you don't have as many reactants there.
Yeah.
Now, why is this guy the yellow one? Because he starts out at 0, along with this guy who starts out at 0 as well. And then goes up to 1. He ends up at being where 1 is, and the other guy ends up being where 4 is up there. All right? That makes sense. Now, here's your next question. Given those graphs, how can I get the rate of the reaction? Which line would I use, and what would it be equal to? Which line would I most likely, I could use 1 of 2 lines, really, but which line do you think I would use here? How would I get the rate? We did it in at least one lab. The what?
Red.
I can't hear you.
Red.
I'm asking you, what would we do? The slope, yeah. The slope of which line would make sense. If I use the red one, what would be the problem with using the red one? It'd be negative. You see, the slope of the tangent to that guy is negative. The slope of the other guys would be positive. So basically your answer is, the rate is the slope of the tangent to the curve at any given point. And the reason you would use calculus, we didn't. We just basically did a linear regression line when we did a lab. But the reason you would need calculus is because that slope is constantly changing, right? We're not doing that. We don't have to worry about calculus. But that is the actual rate. Because think about it. What is rate? It's concentration change per time. Change in y over change in x, which is the slope, right? Slope is the rate. It's the same thing. This is what we talked about when I gave you that graph. All right, so those are all kind of questions I could ask you about on this graph. Okay? Now let's look at the next 2 graphs. Now these 2 graphs, I would certainly hope you guys are good at, because we didn't just see these in this chapter. We saw them last chapter, and we saw them in Chem 1 multiple times. Okay? I put the full graph up here. I don't obviously need you to know label A, B, C, all the numbers or anything like that. Basically, you just have to notice it's energy. This is time, okay? And these are the reactants, and these are the products. And now you should be able to tell me either of those shapes I give you on the board tomorrow. Is that endo or exo, hot or cold, absorb or release, spontaneous or not, even from last chapter, favorite spot, all those kind of questions. Let's see if I can get a few of those right. And without memorizing, you don't have to memorize anything. You just have to use common sense. Like, for example, look at those 2 graphs. Which guy is obviously absorbing energy? We'll call this guy A, we'll call this guy B. B. He starts low, he ends up high. He must have absorbed energy. Which of those guys is going to feel warm instead of cold? Most likely. All right, so because he's giving off heat. He starts high, he ends up low. Which one of those is therefore going to be exothermic? Yeah. And if he's exothermic, does that favor spontaneity or not? Favors. Absolutely. Things drop from high to low, naturally. All right, and what was the other question I said I could ask?
I don't know.
High, low, hot, cold, endo. I think that's about all, basically, I could ask. Oh, yeah. Oh, I know. How does this relate to how catalysts work? What does the catalyst do if I ask you a question about that? It lowers the activation energy. And it lowers it for either one of those. It just gets rid of some of that hill. If I ask you to explain that, you should be able to. Certainly, you should be able to explain it because there's homogeneous catalyst in this, biological catalyst, and of course, the catalytic converter, which is a heterogeneous catalyst, which we talked about as well. Heterogeneous catalysts work by offering a surface, remember, as opposed to a homogeneous catalyst, which works in the same phase. There you have it. Now, the last one I have, in the last page of the test is going to be these, besides the catalytic converter, are the mechanisms, are they consistent or not? Okay. If you look at this guy, I'm kind of looking mainly at here, the rate law expression, and see if it's going to be consistent with what you see down here. Take a look at the first one. Step 1 has, in a fast step, NO and Cl2 are making this guy. So it's like using each of them one time, right? And then I have that guy being reacted with him. So it's like he was used twice, right?
Yeah.
Is this consistent?
Yes.
Yes, it is. Very good. This guy is consistent. And that's all you'll have to write is just yes or circle them or whatever on the test. How about this guy? Is he consistent?
Yeah.
Yeah. Here's why. Look, this simply remember my demo. The demo was you three people standing up here, okay? We had the person in the middle, whoever that was, Shania, I think, right, was much slower than the two people on either side of her. That's a person who's in the slow step. That's a person who is involved in the rate determining step. If I gave a helper to these guys over here on either side of them, it's not going to do anything. All right? So I'm simply looking. This tells me how many times in the slow step. This guy's twice, this guy's only once. That makes complete sense. He's yes. Finally, I have a slow step. What would this is not consistent. I think you can all see that. What would the rate law expression look like for this guy if he were consistent? What would I have to have for a rate law expression for this guy? Rate would equal what? Rate would equal K, what? NO to the what power? 1, and Cl2 to the what power? 1. They both have to be first order because a slow step says they're both used one time in the slow step. Okay? All right. Now, finally, last thing to study from, I would really recommend this one. If you don't do that, that's 10 points off right off the top. All right, the other guys, I've already kind of gone over the transition state theory. That was the endo and exothermic reaction graphs kind of talk. But the collision theory I didn't say much about today. There are 2 parts of the collision theory. Make sure you know what they are. Minimum energy and orientation, look them up. 4 factors, I did not talk much about that. We did quite a bit. You already in the same, seems like so long ago. I showed you several video clips. White phosphorus, remember? Catching fire just by touching a glass rod to it. And then we showed the tracer bullets and stuff after that. All right. 4 factors would be, one of them, are the allotropes, nature of the reactants. You can't put down for the 4 factors, people. Allotropes, nature of the reactants, dissolving in water, and powdering the reactants or surface area. Because they're all one, the nature of the reactants, right?
Yep.
If I asked you about the nature of the reactants, then you could give me the 3 examples I gave you. But if I asked you to give me 4 factors, that one would be the nature of the reactants. What would be another one that would make a reaction go faster? Catalyst, that's 2. What's the other one?
Temperature.
Temperature, that's 3. And what's the last one we spent the rest of the chapter on? Concentration. Increasing or decreasing the concentration. And there it is. All right, so you know what to study for